Okay, hello guys. I'm going to go through question 12 from the mixed exercise. It was one of Miss Fisher's challenge questions, which I thought was it was a really good question though. It really tested our understanding. It was very confusing, so I'm just going to go through it now. The function fx is defined by, so the function is x squared add 6x minus 4, where x is any real value and x has to be greater than a for some constant a. State the least value of a for which the inverse function can exist. Right, so I'm going to recap what are the different types of function. So the type of function, the easiest one to be honest, is one-to-one. Yeah, so one thing maps onto another thing. So an example, which I'm going to show you in a second, will be x plus 3. Yeah. I could have many to one, so more than one value maps to the same one. That would make it a function. But I cannot have one thing mapping to many other things. Now, just writing words like that makes it really confusing. So let me just see what that would look like with examples. So an example of one-to-one. So this would be an example of a function. So the mapping, just to be clear, is everything. And it's only a function if it qualifies by doing one of these two things. So this could be an example of a mapping. One to many would be an example of a mapping, but not an example of a function. Yeah, but a mapping can just basically be everything. So let's have a look at one. So if I took, let's just make up a function. So if I had, the function was x plus 3. And if I said that my domain was, well, for any values of x, in fact, I could just say any values of x, couldn't I? Because it wouldn't actually matter. I could stipulate one thing or another, but let's just say, so here's some examples of those. So I put 1 in, that would map to 4. If I put 2 in, that would map to 5. Etc. Yeah, and obviously any real numbers is saying that the domain is any number. Yeah. Okay. An example of many to one would look like this. So so an obvious one is if I just said that the function was x squared, and I said for any real number. So for any number, whether that be positive or negative, integer or not, doesn't matter. So let's have a look at what a mapping, if I just put some random numbers in there. So in fact, not random numbers, let's just pick this. So I could have picked -3 and 3. Now, this is a type of function. -3 squared is 9, 3 squared is 9. Yeah, and it qualifies as a function because it's many to one functions. Okay. Now, if I think about it, the inverse function of x add 3 would be x minus 3. And that would work because if I put my input of 5, I would get an output of 2. And if I had an input of 4, it would give me my input. Sorry, input of 5 would map to 2, 4 would map to 1. Yeah? So that works. If I have a one-to-one, this is really important. If I have a one-to-one function, it will have an inverse function. And this is important to remember, and you're going to see it in a second. Only if there is a one-to-one function will it mean that there's able to be an inverse function. Because if I do the inverse function of this one here, and what I should have said there again, apologies, is x is any real number. Because if I said for this one here that the inverse function, or what's the opposite of squaring something, that would be the positive and negative solution for of x, yeah? So if I had 9, that would be a problem, because if I had an input of 9, my answer could be -3, or it could be, 3, yeah? So remember what we said, we can't have one-to-many. Therefore, this is not a function. This is a type of mapping, as all of these things are, but it's not a type of function, because I cannot have one-to-many. However, if I put some little caveats in place, say stipulate the domain, i.e. my values of x that I'm going to put in, then I can make it a one-to-one function, and therefore I could make it so it will be able to have an inverse function as well. So if I said that, let's call it, let's just call the function x squared, yeah? And again, I'm going to say x is any real value. But this time I'm going to say that x must be greater than 0. And in doing that, I'm making it a one-to-one function. Because if you think about it, whatever input I have, 0, 1, 2, 3, all have to be positive things. And therefore, the output, when I square it, will be 0, will be 1, will be 4, will be 9. Yeah, so basically just by putting that in, I've made it a one-to-one function, which is going to show you in a second that it's able to have, because this one-to-one is able to have an inverse function as long as my minimum value of x for my domain is 0. I should have said or equal to 0 then. So therefore the inverse function will just be positive the square root of x. Therefore, if my inputs were whatever, yeah, so 1, 4, 9, etc., then if I said to you that x can be any real number and x is greater than or equal to 0, and that has to be the case anyway, because this is what the inverse function of this thing would be here, then that's just going to mean that the square root of 1 is positive 1, square root of 4 is 2, square root of 9 is 3, yeah? So in stipulating that bit in the original function, it's made it a one-to-one function, not a many-to-one anymore. So this has become a one-to-one function. Sorry, it's a bit cluttered, isn't it? One-to-one function, and if it's a one-to-one function, then it can have an inverse function. And that would be clear, because if I think about it, say my function was, let's call my function x squared. And if I just said that that was for any real number, then, God, that's terrible, isn't it? Doesn't matter. Then this is what my graph would look like. Yeah, so that's okay. That's a function. That is a function, because I can have many to one. But my problem becomes if I have an inverse function of that, which will be positive or negative the square root of x. Well, if we remember, and we've been studying hard, we know it will be a reflection in the line y equals x. So this will be what the inverse function would look like. And in making the inverse function like that, I have a problem, because if I have a value of x, i.e. the values of my domain, then it will give me two outputs. Therefore, this cannot be a function. If, however, I stipulate that x has to be greater than or equal to 0, that means this bit goes, which means that this bit will go. And because doing that, so saying that has made it a one-to-one function, which means it can have an inverse function. And again, in this case, it will mean that my minimum value will be 0. This can only be the positive solution for that. So just to be clear, the point of me going over this is when I've stipulated that it can have a minimum value of x, then it has a minimum value of 0. It makes this a one-to-one function, therefore it can have an inverse function. Because if I said that the minimum value was, say, -1, then that wouldn't work. yeah, because then there would have been two solutions, yeah, which would have not made it a function. So, looking at the question, the function is defined by that for some constant a. State the least value for a for which the inverse function exists. Well, basically I'm saying, what can I make the value of a which will make this function a one-to-one function? Well, it helps me a lot to look at the graph for that. So I'm going to use completing the square, and I'm going to express that as x plus 3 all squared minus 9 minus 4, which simplifies to x plus 3 squared minus 13. So if I sketch that on a graph, I've got a line function here, I don't know whether I'm not using it. So if I sketch that on a graph, that would mean that the minimum point would be, this is telling me 3 to the left, so it'd be 3 to the left and 13 down. And then we would go through -4. Yeah, it's just not the greatest sketch. But can you see that the minimum point would be, the minimum x value would be -3. I can put the y value in there as well. But if I'm asked, I'm basically looking at the bottom of the parabola, because if I think about it, use my hand here, because if I think about, in the event that if I just say that the minimum value is -3, then I'm only looking at these values here. If I said it was anything less than that, then I'd be getting two outcomes, yeah? Which I don't want, because then I can't have, then it won't be a one-to-one. But if I say that the minimum value of a is 3, sorry, -3, my minimum value of a, which is my x value, remember, yeah, because I only want to be looking at these bits here, then x would have to equal -3, yeah? Right. Hopefully that makes sense. In the event that it doesn't, please let me know. Just to be clear, it's because, and I don't know exactly what this would look like, but it would look something along the lines of this curve would go this way. Yeah, it would go like this. And then there would therefore be two solutions to it. And I only want one solution because I want a one-to-one relationship. If it has a one-to-one relationship, then it can have an inverse function.